Hello guys, welcome back to another video on digital electronics. And today's session we'll be talking about De Morgan's theorem, Boolean algebra, or the algebra of logic circuit has too many laws or theorem, and De Morgan is one of them. And this theory is mainly or precisely used to convert between max term and min term. So that's being said, we can convert max term to min term and min term to a max term using De Morgan's theorem. This is very useful to analyzing circuits, uh, to optimize a circuit, and then after that, when you analyze and optimize it, and then you can just realize and implement the circuit design, and that will be circuit design classes, but we will not cover that in this section. Mainly, when we go too deep into that circuit design, that will be called something like HDL or hardware description language. But this is outside of the scope of this class, so we will not give you a headache on that. Simply, we will talk about two of the major theorem in De Morgan's. That will be, for instance, number one is A or B long over bar. That will be equal to A naught and it B naught, that short bar. But we will prove how we get to that point. The second theorem is A and B long over bar. That will be equal to A naught over with B naught small over bar. These are two of the De Morgan's theorem. We will talk about them and then I'll try to explain it in the 4 steps how we get from left to right side. So hang tight guys, we will just go over them. What is actually a min term and what is a max term? Just to brush up, we talked about that in previous videos. Min term is sum of product and max term is product of sum. So this is sum of product, this is product of sum. So this is sum of product and this is product of sum. Now this is product of sum and this is sum of product. That's what exactly the De Morgan theorem is about, converting between sum of product and product of sum. 4 steps to convert minimum term to maximum term and max term to min term. And step 1 is we will change all ors to ands and all ands to ors. So every gate that you see is as an OR you will change that to AND gate, and every AND gate you see in the same expression you will change it to the OR gate. That will be step 1. We'll move on to step 2. Step 2 is complement each individual variable. So what is that saying? It says like add a short bar, add a short bar or over bar, whatever you call it, to each variable. Okay, so that was step 2. Now we'll be going to step 3. But before we go to step 3, let's repeat. Step 2 is complement each individual variable. That being said, add a short overbar to each variable. And let's discuss step 3. Okay, step 3 is complementing the entire function. Complementing the entire function. What does that mean? Adding a long over bar to the entire function. Okay, so that was step 3. Step 4 is the cleaning step, or we will be eliminate all groups of double bars. Everywhere you see 2 overbars, you gotta cancel them out. So that will be a cleaning process. We call that step 4. Okay, so let's repeat these 4 steps. Step 1 was all AND will be converted to ORs, and all ORs will be converted to ANDs. Step 2 was complementing each individual variable, short bar, over bar, I'll get O bar, over bar. Step 3 was complement the whole function, or complement entire function, long over bar. Step 4 was eliminating double bars, double over bars, or the cleaning process. So this was De Morgan's theorem simplifying process, or uh, converting from max to min term. Okay, so let's apply this 4 steps to what we have in De Morgan's theorem, which is A or B long over bar that is equal to A short bar ended with B short bar. So let's do how we get from left to right. Following the De Morgan's theorem, step 1 was anything that you see AND will become OR. So we will write this one down as A or B long bar equal to Y. Okay, so the goal is to get this one. So the step 1 was to change everywhere you see AND, make them OR. Everywhere you see OR gate, you make them AND gate. So this is a OR gate. Now we will make them A and B over bar, the long over bar equal to Y. So that was the first step we did. Step 2 was, now we will complement each individual variable. So that will be A the over bar ended with B over bar, and that is the long over bar is equal to Y. So step 2 again was complement each individual variable, or add a short bar to each individual variable. Step 3 was complement the entire over bar, the entire function, complement the entire function, or add a long over bar to the function. So we have from previous step 2, A short bar ended with B short bar, that together long bar, and step 3 is saying add a long bar to the entire function, and that's what we get at the end of step 3. Step 4 is saying cancel the double bar. So we have 1 bar, let's change the color here, let's make it green. So we have 1 green bar here, 1 green bar here, so 2 green bar will be cancelled. This will end up with A short bar ended with B short bar, which is equal to Y. If we go back to, so y was equal to a short bar with ended with b short bar, and y is also equal to a or with b long bar. So that will tell us a or b long over bar is equal to a short bar with ended b short bar. So that's how we got from left to right. Alright, let's do the second one, which was a ended with b long over bar equal to a short bar or with b short bar. Okay, let's prove that, or let's follow those 4 steps. Step 1 is, let's call it a ended with b long over bar, call that, for example, c output. So step 1 is change these and to or to ands. Since we have an AND gate, A is ANDed with B, we will change that to A ORed with B long over bar equal to C. Alright, so the step 2 is complement each individual variable. So it'll be A or A short bar ORed with B short bar and over long bar over bar, that's a long bar, equal to C. Now step 3 is, before I go to step 3, let's repeat step 2. Step 2 is saying complement each variable or add a short bar to each variable, which we did. A is a short bar here, so this one we added a short bar here and short bar there. And step 3 is saying complement the whole function or the entire function or add a long bar to the entire function. Since we have a short bar with b short bar, the entire function is that way right now, but we will have to add one more bar because we are complementing the entire function. This will become double a short bar with b short over bar, that together them have 2 long over bar. So the step 4 will finally cleansing stuff. Step 4 is we will cancel these 2 bars, whatever, like if they're long bars they will be cancelled, if they're short bar they will be cancelled. So if they cancel them out, there will be a short bar or with b short bar that equal to c. Hence we prove that a and it with b long over bar is equal to a short bar or with b short bar. That's how we get from left to right. Alrighty, let's see if you guys want one more example. Do you guys want more example? One more, maybe? Think about it.
Yes! Yes! Yes!
Okay, so since Kramer says yes, let's move on to this example. We have a 2-term, 3 variables, what is it, a product of sum. So once we do, this is a product of sum. So if we have a product of sum, so how we will do this is a POS or max term. We want to move it to min term or SOP. So let's follow those 4 steps there and move on like that. Step 1 was convert all the AND gates to the OR gates and OR gates to the AND gates. So we have 1 logic gate with 3 inputs OR, and we have a 3 input OR gate here. So these 2 will become 3 input AND gate, and this whole entire function will become an OR gate because it's an AND gate. Let's say it again. Since we have a OR functions here, OR logic gate here, these will become AND gate. This AND gate will become an OR gate, and these gates will become a AND gate. Okay, so let's do A naught with B naught and AND it with C naught. Okay, now this AND gate will become a OR gate. This will become OR gate. We change that also. And now these gates, A previously was OR gate, now it become a AND gate. B short over bar, previously with was OR, now it's will be ANDed with C, and that was all over bar there, over bar or the entire function over bar equal to D or the output D. So the blue is determining step 1 because we are changing AND gate to OR gate and OR gates to AND gates. Okay, step 2 is complementing each individual variable. That being said, we will have to add a short bar to each variable in step 2. We'll use a green color for step 2. Okay, so finishing up with step 2, everywhere you see a green bar, we say we complement each individual variable from step 1. And that you see those green bars there, over bar on each individual variable, that is from step 2, because we complemented each variable. And now moving up to step 3. Step 3 was complementing the whole function or the entire function, or adding a one long overbar to the entire function. Use a yellowish color. Okay, so steps 3 is we will add a long overbar to the entire function, and that yellow line, you see that the yellow over bar on the entire function is from step 3 because we complementing the whole function. That will bring us to step 4. Step 4 is the cleaning step or elimination. Eliminate double bar, double over bars. So that will leave us with, so this will be cancelled with that. These two will be cancelled, these two will be cancelled, these two will be cancelled, and that will be cancelled. So that will leave us with A, and it with B, and it with C. That entire term will be ORed with A short over bar, and it with B, and that will be ended with short C. So a C short over bar equal to, or the output T. So that will be our final product or final result of that function. We said our answer will be sum of product, which is sum, and these are the product. Our beginning our beginning function was a product of sum. We had two sum that got product together. Our outcome was a product of, there was sum of product or min-term. Okay, that was it, guys. And for today's session, we covered De Morgan's theorem and we did the 4 steps and we did a few examples. That wasn't that difficult, or was it?
No, that wasn't that difficult. So hopefully see you with the next videos with the more electronic, and hopefully the next one will be motors. We will be discussing servo motors and stepper motors. If I posted something before that, please watch that too. And until then, take care.